Hi, everyone. Welcome to the fifth Address-Space Extension Working Group call. This is kind of the last session for now, scheduled as like the series of calls. We basically have one big kind of topic complex left to discuss, and that is the like the translation map itself, and like the exact form it should take, the like ephemeral, persistent, expiring, these kind of variants with access lists and all of this. And I'm sure kind of Alex will go into a bit more detail here in a second. And if we have some time at the end, we can also kind of come back to some of the other topics we discussed on previous calls. So Alex, do you maybe want to take it from here?
Yeah, I think the first one is a simple one. So it's point 3a, which is a question about what happens. So the starting point is that we have like this in-state translation map. That's what the original specification was suggesting. So let's start from this understanding. And then what happens with access lists? You know, any long address in the access list, should we do we consider that to be added at the beginning of the transaction in the translation map? And should the transaction fail, those additions are also reverted. I think this is a generic question. What should happen to the access list if we have an in-state translation map?
Right. I personally think this is kind of multifaceted. Like basically just to say this briefly, like my ideal design decision here, or like design goal, would be to have the access list, or like the translation map, be designed in a way that once most people have migrated over to the new space, and basically very little activity still touches legacy space, I would ideally like for the kind of translation map to shrink or just kind of go away over time, where we don't, or at least like at the very minimum, not constantly keep growing, basically, if it's no longer needed, like 5 years from now, say, right? And so in that context, I'm a little bit worried about just populating the translation map with all access list addresses. At the same time, I feel like it really looks like a very nice thing to basically be able to do that from the outside, to kind of like give some context into the transaction of filling this map. So maybe we could have like a secondary kind of access list or something. Yeah, it seems a bit tricky though. But in terms technically how to do it, to me it seems like treating it similar to other kind of state changes, where if the transaction itself reverts, these changes also revert. That to me seems like logical on first glance.
Yeah, I guess the distinction is, if we don't introduce anything, we just have the current access list, then there's no way to, at least no easy way to tell whether something will be accessed from a legacy context. And the easy decision is that then every single long address in the access list is added to the translation map. And that also means that many of these may not ever be used. So we'll just keep polluting the translation map, which is probably something we don't want to do, because we discussed this earlier as well, that we don't want to just keep growing the map. And as you mentioned, one option is if we separate these lists, and there is like a separate one which just says, you know, what should be inserted into the translation map. And we also had a small comment at I guess regarding the revert case, and even that is not fully clear. Because I think in other parts of the design, we were, I guess, on the side that if a transaction manipulates the translation map, a revert should like a failure in the transaction should also revert that change in the map, because that's in line how just snapshotting works currently in the system. But there's, I guess, one exception to this is like the nonce in transactions that is never reverted, the nonce increase. So one could argue for both sides whether this additional like translation map list in the transaction that should be always inserted, or that is also reverted.
That's a good point, actually, the analogy with the nonce. Like, for example, if we end up basically also giving the translation map some interface where smart contracts can interact with it, and that includes some way of adding new entries, I feel like we all probably agree that that should definitely revert, because that would then be happening inside the transaction, and so if the transaction reverts, that should revert. But of course, the access list, that didn't. Yeah, I feel like the nonce is kind of a good analogy here, where in a sense, right, you're paying for the access list cost still like that would have some extra cost, right, that kind of accounts for adding this state entry, and so you don't kind of get that money back if the transaction fails. So in a sense, yeah, and it's not something that we would ever want to revert, right? Because it's like once someone has indicated that they kind of potentially want to access to use that address in the future in the legacy context, it seems like you're always just safer off putting it in there, especially if kind of like if the cost for it has been paid. So yeah, interesting. Now this nonce analogy kind of, I think, put me on the weak non-revert side of things.
I do think that as far as when the transaction map gets updated, it should happen at the beginning of the transaction, so that way you can static call into things. Because if you static call into something, into legacy contract, then you can't update the transaction map at that point because you're in a static call context, and that would be a state update. And so we should make sure there are ways to update the transaction map prior to the transaction executing.
Yeah, actually, that's a good point. I think we listed somewhere, and maybe, I think we listed this in the spec and we forgot to put it into this document. But we had this
2C.
question.
Yeah, it's
what
listed as 2C.
That's for the static call to be able to.
Yeah, static call is listed there at least.
Oh yeah. And I think that's maybe something we may want to come back now that we understand like this much better, right?
Right.
But yeah,
in a sense, it doesn't even, it's not even obvious to me that static calls should not be able to populate the list. But yeah, we can come to it later.
Yeah, that might be another like complicated point.
Yeah, because in a sense, right, like I think it's kind of the nature of the translation map, even though it is kind of also state, it is in some sense very different from normal state, right? Where I know the owner of some token or whatever, this state that can be updated and changed and whatever. Whereas the map is really, I mean, unless someone kind of mines for a birthday attack or something, that should always be a fully deterministic one-to-one mapping, where it's not that someone has the power to set the entry and kind of like change where that points to. It's basically just that it's purely informing the network about what the mapping is. And so to me, it doesn't really feel like modifying the state so much as just, I mean, of course, it does modify the state in a sense, but yeah.
I think the primary argument, in my opinion, for having it revert is if it is stored in state, it may just be simpler from like a architectural and coding standpoint to make it so all state changes revert. Like, so you can just throw away your entire change set. You don't have to worry about, okay, some of it needs to retain, some of it doesn't. Presumably you're right. We do have the nonce thing, which is some piece of state that doesn't revert along the transaction. But I'm guessing it opens up more avenues for like ways you can architect internally. You can architect clients if we have it revert.
So there is, I think the next point in this list is maybe like a good point to tie into that, which is point 3b. If we have, let's say this, so maybe just to close off like point 3a for a second, it seems that we likely don't want to mix like the currently existing access list functionality with this. We would rather have like a separate list which says, you know, what needs to be inserted into the map. And if we have such a transaction, then we could consider this next point, which is 3b. What if we simplify the system in such a way that the translation map can only be populated from this list in the transaction? So there's no other way to insert an entry into it.
My fear there is that it will mean that our transaction map is generally less populated, and it's more likely people run into all the problems we have been discussing.
Well, we are still, okay, are we still operating under the assumption we said yesterday that we follow this optimistic case that we are able to distinguish compressed from legacy addresses?
I'm not convinced that's a viable path yet, but I thought we weren't going to talk about that today.
Yeah, I guess for this, like this point 3b, if we are operating under this optimistic path, then this seems to be an okay choice, because legacy contracts will be able to tell that, you know, it doesn't exist. So it would just outright fail. I mean, that's also yet to be discussed what would happen. But in that case, you don't need the map to be, you know, populated like at every single occasion. It is fine to explicitly populate it in such transactions.
But let's just briefly kind of like recap here the exact occasions where the other, like the default plan would also populate the list is just for, it's basically just for opcodes that return short addresses in legacy contracts, but they are now kind of like technically would have to return long ones, and so they instead return the compressed one, right? So like caller, origin, address, and these kind of opcodes. And so
in the spec, we actually have two cases. So in the new context, I think we said when, yeah, I mean, when you call a short address, then it would already insert your account into the translation map. And then from the legacy side, as you said, any opcode for like incoming addresses would do that.
Interesting. What's the kind of the reasoning for putting your kind of caller address in there already? Like, because either it's never accessed and you don't need it, or if it's accessed, then it's accessed via like caller or something, and then you could just add it later, like at that point. Because I'm kind of like, I'm sympathetic to your kind of no, I mean, I generally like your point of trying to keep it simple and basically not polluting the list. There I'm on board. I just feel like basically every time the system already does the compression, so basically like if you call caller and then basically the system sees, oh, caller was a long address, but you called it in legacy context, so you're expecting a short address. So the system is actively internally, like the EVM is internally computing the compressed representation. At that point, I feel like the likelihood is so large that at some point later on, this value will have to be converted back, that we have like a very strong indication that it is needed in the translation table. So I feel like just basically adding it every single time the EVM does the compression seems like a very low pollution way of doing things.
The other advantage of Ansgar's proposal is that it actually makes like the properties of the translation map like reasonably easy to reason about, because the rules are then that you are if you have a compressed address and either that compressed address has been attained in the course of executing the EVM, you know it's in the translation map. And then you just require that anyone who comes into the system from the outside and sticks a compressed address into the EVM has to make sure they also include it in the in the access list and then it will get stuck into the translation map. And then you can, relying people do what they're supposed to do, have pretty strong guarantees that when you access a compressed address, it will be in the translation map.
Right. Of course, this is again on the spectrum of how much do we want to add extra overhead to reduce the likelihood of making mistakes. So similar to how basically this whole question of do we want to make compressed addresses kind of distinguishable by prefix or whatever, this also adds overhead, but reduces kind of error probabilities. And I feel like this whole kind of conversation here again is a similar kind of trade-off where I do agree that basically it is preferable to have a simple translation map and ideally a small one. At the same time, relying completely on the users seems to be very error prone to me. And so then it seems like it's not worth basically the savings and complexity. Of course, hard to tell with these trade-offs always.
I think I'm tempted to take the position that firstly, there is a gas cost for putting something into translation map, and that gas cost is priced correctly, that it doesn't actually matter if people stick too much in the translation map. And secondly, if that gas cost just means that interacting with legacy accounts becomes more expensive, that's just creating an incentive to switch over to the new system with everything, because it will become if Uniswap switches to a new account, it will become cheaper to interact with Uniswap. And eventually, of course, we're going to have state expiry, which is going to make interacting with legacy accounts even more expensive. And the translation map will slowly shrink as less and less people interact with legacy addresses. And so less entries get added, and the translation map that already exists is going to recede into state expiry.
See, this is
kind of confused. What is Ansgar's proposal, or what is?
Yeah, I don't think that there's technically a proposal by me. I think it's mostly just kind of like going with the main Epsilon proposal instead of this additional alternative proposal of only adding things to the translation map via access lists. So it's basically rejecting 3B, I think is what Peter there referred to as my proposal.
So not to have 3B, but rather just populate the map based on the opcodes.
Well, and the 3A, what we discussed about that there should be ideally not the existing translation, an existing access list, but like a new second type of access list on the transactions that also populates it. So doing 3A, I think we kind of you summarized that well earlier, that we agreed that it seems very useful to be able to do that from the outside as well, but basically not going with the more extreme version of 3B where you completely disallow population from any other source.
Yeah, and the specific proposal I was talking about is that we have a rule that whenever the EVM in the course of its execution takes a long address and compresses it to a short address, it also adds that long address to the translation map.
That is part of the spec already. That's the core idea in
Right,
the spec.
That's what I was saying. It's not
Yes.
really my proposal so much. It's just the existing Epsilon proposal, just kind of without this modification.
Well, I mean, this is the original proposal even from Vitalik. So I mean, that's the core idea of this translation map. Okay, maybe just one question on 3A. I guess this this new list in the transaction that should only need to list the long addresses, and then transaction processing should derive the compressed one based on that, right?
That seems correct to me. And of course, that also runs into the same question that we still have to answer of what happens if there ever should be a conflict in the table. But besides that, yeah, I think I would agree.
Yeah, it's just a trade, CPU versus network bandwidth.
Yeah, well, and if you, let's say you do have like a map of like long to compressed, then you would also need to verify that that mapping is correct, right? So there doesn't seem to be any point including the compressed one in the transaction.
Right.
Yeah, but regarding 3B, yeah, can you clarify why do you think it's better to still have the opcode directed one as opposed to have the user directed approach? Because 3B is basically delegates the task to off-chain, whereas the opcode based one is keeps it on chain.
Right. So I just feel like there are many scenarios in which the user is not in control of all parts of the transaction flow, basically. And so especially if sometimes errors just silent or like transactions just silently fail, what users might do is they could just make parts of the transaction kind of fail, right? So I don't know, I do some swap or whatever, but I don't want the other side of the swap to actually receive the funds. So I don't, and that happens to be some interaction from long to a short to legacy. And so I just don't populate that part. And so then that part of the transaction might fail, but for some reason that's like a self-contained failure and that doesn't like bubble up and make the whole like overall transaction fail or something. And so then I get my part of the swap, but I don't have to pay out the other side or something. I don't know, I'm just making that specific scenario up. But basically, I'm just saying that the user might just not be interested in making all parts of the transaction work at all times. So it feels kind of fragile to rely on the user to make all of this work. And in addition, it also seems to run into this kind of issue around dynamic state access versus static state access, where sometimes it might just be really hard to tell which address actually might be required. And so it's hard to kind of statically put that in a list when creating the transaction.
Yeah, that was our concern, and I mean that's the same concern for like the ephemeral one.
Do you have actually like any insights if the current access list is used in practice currently? I mean, is any like tool or wallet generate the, for example, full access list to make the cost cheaper?
Well, wallets can. I think they did.
But...
No, I think they did implement it, but I mean, Matt is not on the call, but I don't fully remember. Matt had in the IP proposal, he identified that the access list, the pricing of the access list currently, the pricing of the access list currently makes it not too useful below like 4 entries. It's just more expensive that way. And he tried to reprice it. But yeah, I mean, I would expect that not many people use it. And maybe one last comment on it. Martin Sven said that his, I mean, as a response to this proposal, that his motivation for the access list wasn't like a gas savings feature, rather a just a backwards compatibility feature should something break during the increase of the gas prices.
I think Geth might have an implementation if you're just looking to create an access list. I think you can do it through the Geth JSON RPC.
I think Pavel's question was whether are there transactions actually using the access list today? Any, what percentage of them?
I see. Then yeah, I don't think anybody is.
But also just to be clear, of course, I mean, this is still a really new feature. I mean, when was Berlin again? Feels like it was like 2 months ago or something. So, and any new feature like this, especially if it only has marginal benefits, and as you were saying, is still mispriced a bit today, will take quite a bit of time for take up. So I would hope that a year from now, a few more people use access lists than they do today. But I do know that there is some usage of it even today already.
Okay, I mean, as we go, at least today, I kept updating this list. I think like a line called update or note to each of the points about what we discussed. And yeah, I guess with Ruby, the biggest concern is about the validity of this list, especially like DSA, and maybe this in the case of DSA, and maybe this needs to be explored further. If there's maybe no more comments on 3A, 3B, I guess we could move on this 3C, and which is the ephemeral map, and then go into an expiring map as the last option of discussion. Does it sound like a good way?
Sounds good to me. And then I also just briefly want to reiterate that to me, it's really two separate concerns. That, like, for one, this ESA SSA, like the predictability of it, but then also the potential for malicious omission by the user, basically, for in some situations. So these to me are two separate concerns about purely populating from the access.
So the malicious omission, if we do have the capability to distinguish compressed from legacy, what issue can happen in that case?
I think, so basically the way I see it, it's like, again, I'm not an expert on this, I'm just kind of brainstorming here, but I would worry that some legacy transactions now fail. They try to send ETH and it fails because they can't kind of look at the lookup of the compressed address fails. And because usually there's just no reason for the transaction for the transfer to fail something, this might end up failing silently. I mean, I'm not sure this is like a common pattern, because Solidity usually just by default throws if the call fails, but then maybe the surrounding function could catch that or something. So I don't know if this is at all like a practical worry or not. It just feels like you can make things fail, or even interactions between contracts that trust each other or something. So basically you can make like things fail that used to never fail. And so that way kind of legacy contracts might not have the required precautions in place. I don't know. This could be completely off. This might be baseless, but it's just a worry that I'm having currently.
Yeah, I'm not sure I got a good idea about the malicious omission. But the validity is I guess a big enough concern anyway.
Sounds good. But then yeah, let's move on to the ephemeral, because that's definitely a really interesting idea.
Yeah, the ephemeral has I guess the same problem regarding validity. But otherwise, the idea is that this translation map is ephemeral. That means it's always empty, and combining of what we discussed so far, basically always start off with an empty translation map, and it is populated based on the submitted. Well, okay, so I suppose this ephemeral has also two subcases. So the first one is what I said so far, is that it's populated based on the this list submitted as part of the transaction, and then the on-chain, I mean, these opcodes, they wouldn't populate it. So that's case one, and the case two is that those opcodes do populate them, the translation map. But at the end of the, and that's a good question. Are we, yeah, I guess at the end of the given transaction. So this is, the translation map is specific to a given transaction and not to a given block or anything else. So at the end of the transaction, I mean, the translation map is empty again. It is really just for that given transaction. And I guess the benefit we get is we don't need to be concerned about any of the state pollution aspect or any space or even IO in the state, because nothing needs to be looked up. Everything is in memory. And yeah, we weren't sure, but maybe it can be simpler, because in this case, we don't need to care about revert rules, because we can just keep this translation map in memory throughout the transaction. So that might be a difference. And the last positive effect is, since you need to submit this list with every transaction, this is an incentive to migrate fully to the long address word, because in the new execution context, you don't need to submit any of these things, and it's much easier to interact with that side of the network. But it definitely is much more complex to interact with the legacy side. But yeah, the biggest negative effect is maybe transaction validity.
Right. And so just my take on this, as you were saying, basically it runs into the same problems. Why I still think it's interesting is that basically the payoff is my kind of view is basically bigger, because we get rid of all of these worries about the permanence of this extra state object, where you just have this map that always just ever grows, and you have to carry that on forever, which is very antithetical to the whole like motivation for state expiry that led us to this address space extension in the first place. So I feel like there's more incentive to try and make it work, just because it would be really nice if we could get this feature that we don't need this state object. I personally like, I like, in my view at least, and I just realized this now, as you were saying, Alex, I think like 2 minutes ago, something, that this also depends on whether we end up being able to distinguish compressed addresses and just short addresses, right? Like with this prefix. To me, it seems like, I think I would be very strongly opposed to any of these kind of ephemeral only kind of proposals if we don't end up with that. So if you really can't distinguish short and compressed addresses, because then it seems like we just basically always will end up sending things to compressed addresses or something. But if we end up being able to distinguish it, to me, that seems like we might end up in a world where just transactions really fail unless the user is careful about sending the correct producing the correct access list. And that might be more okay, right? Because then it's just basically just means tooling has to be good, but at least like if it's not good enough, you notice. So I feel like and again, I think we like, I would really want to try and kind of make this work. And of course, my preference here would again be the version that also populates from opcodes, just because that seems to make it much easier for things to normally not break in the happy case, basically. But yeah, I think that's all my thoughts.
Yeah, so based on comments, the feature that it populates on opcodes, I think for this one it's pretty cheap because it's never stored, so never stored in the state. So I think that makes sense. So I'm just like based on comments from you as well, that in this case having the ephemeral list, ephemeral map to be populated based on the transaction list and the opcodes, I think it's a good idea, because it doesn't really cost much more to include opcodes in this process.
Yeah, that sounds good. Yeah, that's a good one actually. That like when you don't have to store it then permanently, that makes it cheaper to err on the side of caution and just add more things, even if they might be unnecessary. That's a good point.
It also makes the transaction list shorter, or maybe even empty in this case, right? Because you might only, I mean, it's in the end, it depends on the quality of the tools producing this and like the determinism of the execution. So this is like big issue, I think, I find with these. Some of you like had more concerns about that. I'm not really like familiar in the practice with how this, even the gas estimates are not really accurate at the moment. That's my observation. So it's also maybe sometimes difficult to have the proper list of for the translation one. But anyway, so I think we might need to keep these two different kind of specification for now. That would be my preference. So improve the original spec, but also keep this ephemeral version. I'm not sure how to decide later which is better. Maybe some simulations on existing. Yeah, I don't know. But I think that would be somehow resolve some of the questions, at least for now.
Right, and also I think on the other side, basically a better understanding of how big the a persistent translation map would become and how much that kind of like will be an overhead that will be with us forever, right? If we at least had a good understanding that likely this will never be bigger than 10 gigabytes or something, then we could say, yeah, sure, it's not ideal, but maybe it might be okay or something, right? Like so basically also I feel like a better understanding of the exact cost of a persistent translation map would also be informative for making this decision.
So just to maybe write down what we discussed before we forget it. I mean, we can always listen back to these calls and fill out the bits, but is a good summary the following, that the ephemeral translation map should be just append only during the lifetime of the transaction, and the more ways we can add entries, the better it is. So we should do it on every possible instruction, just so that the number of inputs required is reduced, and it doesn't matter, you know, how much we pollute this ephemeral list, because it's thrown away and it doesn't need to be stored on disk anyway. Is that like a good summary?
I would be a little bit more cautious in wording it that way, just because like you could kind of really go overboard with what to add, right? You could even just say like every time you do a call, you just like chunk the call data and just add it in case there's an address in there or something. So these kind of things, right? So basically like within reason, I would say, kind of populated with whatever makes sense. But generally, yeah, I would agree.
Yeah, I think the call data would be quite a bit of an overreach.
Yeah, I
Yeah.
think it won't be much more than we already specified, or maybe like the specified list is already full of that. I mean, I think it's matter of adding addresses that EVM kind of thinks are addresses, and maybe some like initial values for transaction origin, the miner and stuff like that.
Right.
Although
Yeah,
we might not have miners.
The Coinbase address, basically.
Yeah.
Okay, so what I wrote, ephemeral map should be populated via all address producing instructions, the Coinbase, and the submitted list. Is that like a concise way?
Is the Coinbase 256 bits? No clients.
I mean, it's an RLP field, right? In the header, so I guess it's unrestricted there.
Well, I mean, the header also has difficulty as 256 bits. But we just found out recently that Geth implements that internally with 80 bits, and it is very hard for them to change that. And so I'm concerned that they may have done something similar with the Coinbase.
So addresses are one of the very few things which are actually specified in length in the yellow paper, and they are 160 bits or like 20 bytes. So that may be the case for Go Ethereum, but the yellow paper doesn't really specify a limit for, I think, pretty much anything else, but the addresses it does.
Yeah, so I guess whatever it's the Coinbase opcode can actually
Addresses for Coinbase.
yeah be
which
like
means
for
that-
long addresses be long address.
Also, just to briefly mention that, like, I feel like this is basically the most cautious approach that we could take here. I feel like we should definitely revisit these individual things and only end up adding things that at least remotely make sense. To me, for example, at the very first glance, it doesn't really make sense to add the Coinbase there preemptively, because like we can just do that whenever someone calls the opcode or something. I think there's a Coinbase opcode, right? There should be. Sounds reasonable. So these kind of things. So I add, but like at least in the initial spec, like doesn't hurt to have it in there, and then we could always kind of see if it really makes any sense.
Yeah, I think you're right. You can't reliably use the Coinbase address in the execution except calling the Coinbase opcode.
Right. And so generally, I basically I do feel like that for like 99+% of cases, it's really sufficient to only add things for these opcodes that actually do some compression. And so I do still wonder if even for the ephemeral, where it's almost free to add more, if it really makes any sense to add like everything that remotely looks like an address, just so we are safe. But I don't see a harm in kind of like starting at least with that and then whittling it down over time.
So this is the very few times I really need to leave on time. So we have like, at least I have 10 minutes left. Should we talk about the expiring
Right.
translation map?
I would like to just ask, have we talked about or thought about block producer provided ephemeral translation maps? So
So
user doesn't
so
have to user
instead
doesn't have
of-
to apply them, but the block producer does.
So it's not,
Kind of like we talked about for witnesses.
so it's not, but is it attached to the transactions or is it attached to the block level?
it would presumably be attached to the block level. I mean, the block producers may get that information from users, but the onus is on the block producer to actually produce it, not the user. Like in terms of who's responsible.
So I think the problem there is that like the contents of the ephemeral translation map have the effect of causing your transaction to revert if data is missing, and that costs users money. So if
So the block would be invalid if any of the transactions tried to hit something that wasn't in the map.
Wait,
That's
but
what
I
I mean by
mean,
it's the block producer's
you
problem.
can just trigger that as user trivially, right? You just give in the compressed address that no one knows or like just a fake
Right,
compressed
so
address that, yeah.
The block producer would not include a transaction like that because that would result in an invalid block.
Sure, but
Yes,
that
but
could
then
happen after 10 million gas.
Yes, so you now have a denial of service attack.
It has a header that has all the ephemeral transaction map for that whole block. And either the block is valid because the map is sufficient, or the block is not valid because the map is insufficient. Where the block producer fills that map in from is a separate problem and not a protocol problem. That's more.
So this doesn't work because the block producer can only find out that they can't.
Overall, because if everybody's interacting with the same Uniswap contract, you only need to include it once.
No, the problem is I can submit a transaction to the block that is very long, very expensive, and the block producer is required to execute it for a long period of time, get to the end, and discover that the entire transaction is valid because they don't know the answer to some transaction math question. And then you can denial of service that by submitting loads of transactions that require lots of producers to execute lots of computation on, just to discover that they're invalid and can't be included.
Right. So I'm with Peter here. I don't think that specifically works. I think it could be interesting to talk about, like, should miners provide like a supplemental, be able to provide supplemental entries that like persist through the entirety of the block or something, but it can't be required for execution or anything. And I do think though, and I like, just because as Alex kind of has to leave on time, because I do want to kind of briefly talk about the expiring list, and I think that's actually a good kind of transition, just because to me, basically the expiring translation map is a bit in a similar direction, right? So basically, instead of having the entries only persist within a single transaction or only within a single block, basically go one step further and have it be. I mean, of course, now this brings state expiry into discussion, and I know, like, Alex, that you try to keep the specification separate, and so I basically think that would mean that in the pure address space extension specification, this would look identical to the persistent map, but with the understanding that once we introduce state expiry, we would treat this storage as part of state expiry. So basically, what that means is that any entry to the translation map that hasn't been touched in over a year, or like over 2 years, kind of depending where the like period boundary is, but once it basically hasn't been touched in quite a while, it gets expired and forgotten, and then the idea basically is that you would need to add it again if you want to use it. And so I thought about it a bit, and I think it doesn't work quite identical to normal state expiry, because normal state expiry, a transaction just fails if it reaches a point where it wants to access state and it doesn't find it. Here, you wouldn't actually fail. You would basically just say, like, you would just return the value. It's not in the map, right? We don't know if it ever was, but it's not in there. And also for adding new entries, you wouldn't have to provide witnesses about if the entry has ever been added before. So you're just allowed to override.
Can I interrupt you for a second?
Yeah, go ahead.
Yeah, just for the sake of the discussion, do we assume that the translation map just exists as a regular account and with regular storage, or do you envision like a separate state which can be then revived? I assume the first, it's just a regular account as we discussed, like a special contract or whatever.
Yeah, well, it's a bit tricky because I think the storage itself could end up being stored by clients as normal as regular storage would, under maybe the precompile address or whatever, if we end up giving it a precompile address. But the rules for actually accessing it, overwriting it, interacting with it would have to be modified. And so basically, normally, if you basically want to write to a field in an old contract that basically is not within a fresh state anymore, which the translation table after two years or so would be, then you would have to always provide an exclusion witness. And for the translation map, you would not have to be, right? Because unless for birthday attacks, one, like basically it's always deterministic, right? So there's always, like, any long address will always, any short address long address mapping will always be the same. So you don't have to prove that there hasn't been an entry in this mapping yet. You can just override it. So it does behave somewhat differently. So you could, I still think for like client logic, you could just store it as normal storage, but then for kind of the way how you interact with it, that would have to follow slightly different rules, if that makes sense.
So if it's like regular state objects, then all of this is in the legacy epoch, right? Epoch 0.
Yeah, I mean, so insofar as you can say that about precompiles, but I think that's correct.
So then the cost of reviving that, I mean, that's just like another incentive to bend on the legacy epoch, right?
Wait, I'm not sure I understand that part. Like,
so if
would you?
So if this okay, maybe I'm missing something on state expiry, but you know, the longer in the past, you know, the more we go into the past, the more, I mean, it's only just the last two epochs which are cheaply available. Anything besides that is much more expensive because it has to be revived into the current epoch. And if we assume that this translation map exists in the legacy epoch where the legacy contracts are, then that's like another like cost increase in how to interact with those. And that's like another incentive to get away from the legacy epoch, right?
Right. Although I would, well, I'm not sure. I'm not sure I agree here. Generally, yes, but I think that might be one of these special cases in which it doesn't follow the normal behavior of normal storage, and that I don't think you would ever want to revive any entry. You just override it, because there's no reason that you'd ever want to prove anything about the mapping. You can just add the entry anew. So I think this, like, specifically would just not have support for resurrection, or for, like, yeah. So it would never actually require like workable witnesses, the translation map.
So the problem with that is that it makes quite nasty versions of the birthday attack possible. And in particular, if we're doing this distinguishing like compressed addresses from non-compressed addresses thing, like the birthday attack will be very expensive, but like actually feasible. Like at the moment, if you want to do the birthday attack, you need like, you know, state actor level money. But I think we're proposing to make it 4,096 times easier by making this distinguishability thing. So we need to like create a system that is robust against the birthday attack. It's not really good enough to say, well, this doesn't matter unless there's a birthday attack, because if there's a birthday attack possible, then a whole bunch of things become insecure.
Right, but And I assume we'll probably go over time again, but then Alex will have to do its really best. But basically, my point here is just that the birthday attack is even more of a concern for the ephemeral list, because there basically you could just have one account that it gets compressed, then is added to some storage of some contract for some balance or whatever, and then even in the next transaction, even in the same block, you could have a different address claiming it with the same compressed form. So the state expiry, basically, I see that as a compromise where as long as you keep it active, it can never be a target of this attack. So basically, like as long as you access it once every 2 years, basically, or at least once every year, let's put it that way. As long as this address is touched once every year, it can never be the target of a birthday attack. And so basically you only have to worry about if you if you use very old things. And I feel like at that point, it's starting to just basically be an acceptable kind of trade-off. But basically my point is just, it is like a strict improvement in security for the birthday attack of the ephemeral list. But it is indeed worse than the permanent in state.
So, sorry that I'm
No.
deviating from the birthday attack, but I really need to leave in a very few minutes. One part I'm still not fully clear about is that you said that there might be like different ways, whether it's a regular state object, like whether this translation map is like a contract, but you may have said, maybe I misunderstood, that there's like a different way to deal with this as part of state expiry. Can you maybe elaborate on that?
Right, I'm just saying because it needs these modified state expiry rules anyway. I'm not sure. I would have to kind of think about it more, but it could be that it's just easier to implement for clients to treat it as special state and very explicitly kind of implement its own expiry rules, and that those would still be the same rules then that we just talked about. So it basically needs these slightly modified state expiry rules. The question is just, do clients basically treat it as normal storage with just modified rules, or do they just treat it as like its own thing and very explicitly give it different rules? I'm not sure.
So you're saying that in both cases, we just likely have a contract or whatever at an address with storage, but because this is a special address, there might be different rules regarding state expiry for it. Is that what you're saying?
Yeah, kind of. I feel like if we end up having a precompile or something that exposes it to other contracts, then the precompile, I'm not sure if you want to think about it as the precompile having storage and then basically interacting with that storage, or if you want to think of it as the precompile just accessing this special state that is treated differently inside the client. I feel like those are kind of the same in a sense. So yeah, I don't think it necessarily has to be contract storage. It could, I mean, I assume you would want to have it live inside the Burkle tree.
Yeah,
so in that sense, yes, but I'm not sure. I'm convinced that it has to live inside the Burkle tree.
I think in the simplest, like in state version, it is really just a contract. It's added in a hard fork, but it is a contract with the regular storage. And in that case, you can just apply regular state expiry rules to it. There's no special handling needed.
Right, and I just feel like basically you ideally don't want to do that because that has very suboptimal effects once the map is like 2 years old, basically, because then you'd have to always have these exclusion and resurrection witnesses and whatever that just become really expensive. And yet you can of course say, yes, that's a good incentive for people to migrate, but it's just unnecessary because of the specific nature of the translation map. It's basically just adding overhead to the cost of interacting with it that is just not necessary. And so while it simplifies the state expiry part of it, I prefer a solution where it gets its own state expiry rules.
I think the simplification is very much worth it in this case, personally. Like, I understand what you're saying, that it's unnecessary, like the proofs, but I suspect proofs for these are going to be very uncommon, and B, we just get so much of a win from a client complexity standpoint.
Well, I'm just saying that basically means that once we're 2 years in, ever adding new entries to the list will be extremely expensive. And so basically all of a sudden interactions between the new and the old space will become really expensive, where they just weren't before. And that's just a property of the system that I personally very much don't like, because it doesn't even necessarily incentivize migration. You can, if you live completely inside the legacy world, you don't have to pay that because you never interact with the translation map. So it kind of effectively just very much disincentivizes interoperability between the two layers. Yeah, I very much don't like that property, but I see the point that it might be simpler to apply the exact same expiry rules.
Yeah, I need to leave, but yeah, thank you for explaining this, because I was wondering, what do you mean exactly by the expiring one? And I was kind of worried that this would be some like special rules introduced somewhere, but yeah, in this case that we delegate the expiry, the rules for expiry and revival to the larger proposal. I think I don't really have anything in essence against going this direction, but it's clear that we already have like two big questions on this topic, right? What we have been discussing in the last few minutes.
Yeah. Mm-hmm.
Yeah. Yeah. Let me know if just on Discord if another call is organized or anything. But I really need to hop off now. And it's been great. Thank you, guys.
Sounds good. And thanks again for leading all these calls. I think this has been really productive, mostly
Yeah,
at least.
agree.
Yeah.
Yeah, it was
Thanks,
great.
Alex.
Talk to you. Bye-bye.
Bye. Okay. I think we shouldn't kind of like try and go over that time too much though. I'm happy to discuss this like a couple more minutes.
Can I make a request that rather than like continuing the technical discussion, that we discuss how like the process is going to going forward now we've reached the end of these calls, and leave the technical discussion until Alex is back at a future call?
That sounds reasonable to me.
I would really, as I mentioned a couple times before, I would really like to resolve the things that I see as blockers before doing much else. Like as far as process goes, I would love to find a solution to these things we've come up with that stop us from implementing this.
So what are the big blockers for you, Micah? Basically, from your perspective.
Oh, I can never remember them. So in Discord, I posted that big long list of all the different combinations of things you can do between various addresses. Having an answer for all of those, basically. Every time we go through, we find one or more that doesn't work with every solution we've come up with. I forget at the moment because it's very late for me what the last one we came up with was, but it was a blocker and we haven't resolved it. I think it was a new token, like a long address token, which is sending to a compressed address, I think. And I'm also not convinced that we can differentiate between compressed and non-compressed addresses. I think we have to sacrifice way too much entropy in order to get that. And so I think that's I personally believe that is a non-solved problem. And because we haven't solved that problem, the ability to differentiate, then that leaves open just, a ton of other problems that we've been talking about.
Okay, so just briefly, kind of,
I guess, for answer.
Yeah, so just briefly, so one, I'm very happy if you want to, if you ever like just jump on a call like the two of us and just go through this humongous list of yours and just see if there's really anything that doesn't just work out of the box, because I'm reasonably optimistic that by now that I think we have a solution that will just work with all of them.
Are you assuming that we can differentiate a compressed address from a legacy address?
Yeah, I'm saying like in our ideal happy case, I think all of these work.
Yeah, so I don't think that happy case is realistic. I do not think we can distinguish compressed address from legacy addresses in isolation. Like I think that is, like we've talked about it, but like I have not heard a solution that I think is actually viable. Like the best one we have is we can sacrifice some bits of entropy in order to do like a CRC or, you know, a prefix or whatever. But I think the number of bits we need to sacrifice in order to get a sufficiently good CRC check that's not going to conflict with the legitimate legacy address is so high that we just have lost all security, basically. Like we have to drop down to, you know, from 160 bits down to, you know, 100 bits because we need the rest of them for a CRC check. That's obviously not going to work.
Wait, but how is that a problem? Like, I mean, it is a problem, but like, it's only for entropy in the translation map, right? It doesn't take away from the entropy for legacy addresses. It doesn't take away from the entropy for new addresses. It only takes away from the entropy for basically counterfactual contracts that in the new space that want to be able to interact with the legacy space.
So are you basically arguing that, like, just hypothetically, just throwing some numbers out there, you think that if we only had 80 bits of entropy for compressed addresses, that would be okay, basically? Is that,
So basically,
like,
of course,
you
we should
don't think we need
basically
much?
we need the entropy that makes it impossible to specifically target existing. Wait, I don't even think that's necessary. So I think the basically what we need is just that we never have a collision just on accident, right? So because that just breaks things. So but as long as we retain this, I think, except for the ephemeral list, like that's the ephemeral translation map is indeed, in my mind, and I think we kind of unfortunately only touched upon it like looking back, and we didn't mention it when we talked about the problems with the ephemeral list. But I do think that the ephemeral list is vulnerable to birthday attacks much more. And so if we end up going with the ephemeral list, I'm back on board with all of these concerns. If we go with either the expiring or the full permanent resistance in state one, I feel like even 80 bits of collision resistance would be sufficient, yes.
I mean, I'll think on that. I'm not convinced yet, but maybe I can be convinced that we only need enough security to prevent accidental collision. And it's not really security even, it's just, we just want to make sure that people don't have a bad time because they collided and then can't do things.
But does it mean like pre-image collision? Like 80 bits of pre-image collision? That's what you mean? It's enough? I'm sure it's enough, but
I think the 80 bits, I think we're just Micah trying to make a point. I don't think any of the proposals has like specific 80 bits. So like, it's just like, basically, is it okay to sacrifice some of the natural 160 bit collision resistance that we would get with a pure translation map? And so I think if we go with like 3 bytes of prefix, where does it leave us? That's like, yeah.
Is there any like even prototype of this specification? Because I'm not sure how it's supposed to work. So it's
is
like,
that for the
give,
prefix,
like,
you mean?
Yeah, you mean like there's like some bytes that is checksum, and if the checksum matches the rest of the bytes, that's the compressed address. Otherwise, if it doesn't match, it's not, right? That's the idea.
Yeah, I'm personally even more in favor of just the even simpler approach of just basically having a fixed prefix of like 3 bytes that have never been used as an address prefix on mainnet before, and just designating that as the compressed address prefix.
Yeah,
but
I don't think that would work, because like all of the hardware, like all of this like HD and hardware wallets, you can't really control like what address it will generate, or it's even like possibly generate. So like they would need to add some additional code to reject such accounts, right? I mean, it might not be used right now, but like there's possibility like it will be generated by some existing tools, and then it will not.
Right. So
that's
right. So this is where it gets into how many bits would we need to sacrifice in order to make that very unlikely enough to occur that we don't have to think about it. So 3 bytes, probably not enough. Like it's reasonably likely that 3 bytes will get hit naturally over the next couple of years. Whereas, you know, if we sacrificed out of our 20 bytes, if we sacrifice 10, it's very unlikely that someone's gonna hit this specific 10 bytes in the next 2 or 3 years or 4 years or whatever. And so the question is I think we'll have to sacrifice quite a few bits in order to achieve that level of no one's going to accidentally run into this. You could attack it, but you can't accidentally hit it. And that's what leads to the question of, is it okay if this map can be attacked? Like, are there no ways you can benefit from such an attack? Can you do nothing bad by creating collisions in this map? And if the answer is no, you can't do anything bad by creating collisions in this map, then I think it's reasonable to pursue. That's the bit that I'm not convinced yet on, but I maybe can be.
So I think you can get the you can get to a point if you are very careful with how you design the translation map, and you're very careful to make sure that stuff gets into it and that it's permanent and it can never expire. You can probably, or if it does expire, then you can resurrect it properly and stuff. You probably can get there. The problem is, once you're cutting 10 bits off, like, getting an intentional collision is probably not even difficult. It's probably something that someone on like one GPU can probably do. I'm very ballpark there, but it sounds that sort of level. Yeah. And at that point, you are, once you're at that point, you really have to worry about like the birthday attack problem, because like, we really want to keep this counterfactual contracts thing as secure as possible. And it looks like if we're going to distinguish between the counterfactual contracts case and if we're going to get this distinguishing between compressed addresses and normal addresses, we're going to lose counterfactual contract security in the case where it's a compressed address.
Yes.
And just like we're like going to completely lose it. No one is going to have any security, and like some random person who is prepared to like spend a few £1,000s can break your counterfactual contract if they want to.
Right. So I mean, I feel like we have to kind of take a step back here, because I feel like there's too much of a kind of detail discussion now. But I agree that like there are definitely unsolved concerns around this detectability of compressed addresses. So I agree with both of you there, at least in that point. Also, though, like on a different point, I don't think that any of the kind of solutions that we came up with in general rely on detectability. I think a lot of them just become much cleaner. So I very much think, yeah.
That's where I disagree. I think lots of stuff breaks if we don't have that detectability. Like all the other things we ran into. Like that's how we stopped that discussion, was by just saying, let's pretend that we can distinguish, and so we can move on, because we kept getting stuck every time we tried to solve it without being able to distinguish. We had problems. Like, I don't think that solved it.
I think the problem at this point is we have like got to the end of like random discussion about the problems that we could do. Like, I think what needs to happen at this point is that the people who think they have solutions need to go away and write down and like battle test their solution, and like come back in a week or two and say, this is what I've done. This is what I think the solution is. And then we can go and analyze that. I think if we keep having calls, we're just going to end up going round in circles. I think we've got to a point where like we know what the really big problems actually are. And I don't think we need to keep having calls to like work that out. But I think the two things we should do next is, firstly, we should like try and write down a definitive like list of all of the like serious problems that address space extension has that we need to solve, include it. And like, just, I think everyone who thinks that there are serious problems needs to write down what they think their blockers are. And then we need to compile those into a list. And then someone needs to, people who think they have solutions to these problems need to sit down, take that list, write a like outline proposal of what they think they're going to do, and try and persuade people that their proposal solves all the problems on the list. And when we do that, one of two things is going to happen. Either we're going to get a proposal that like everyone agrees that works, or we're going to end up in a situation where like we discover that one of these problems is like actually a fundamental problem we don't have a solution for, and then we can focus on that problem.
Right. I think I generally agree. I think we talked about it in press as well, that like it makes sense to, after this kind of call, basically to after this call specifically to stop and basically also, I mean, at least I don't know, for some people I think involved, there will be HCC, which will, at least I don't know, for example for Matt and me, will take away attention for the next week or so, a bit more than a week basically. But I think indeed we are at a point where it makes sense to just work through these things, kind of specify, like write some more specifications, and then probably come back together in 2 weeks or so. Maybe even have one full statelessness call. I'm not sure. Maybe we should have one more working group call beforehand or something. But it could also make sense to kind of pull this back into the statelessness call and just basically say, okay, we had these 4 alternatives, and now after 2 weeks, it looks like this is realistic. This there's problems, whatever. But basically, our initial results from this address space deep dive are as follows. That to me makes a lot of sense. And I don't know if people have preferences of whether we should, like, say 2 weeks from now, whether we should pick this back up in the form of the working group calls for now, or if it would make more sense to bring that back into the full statelessness, or I don't know, state expiry.
I would like to see, like Peter suggested, I would like to see some solutions proposed before we regather, or like a concrete thing to talk about. Like, I'm at the point with these calls where I don't have any solutions, and I'm so far not convinced by any of the proposed solutions, and I'd like to see them written down and be convinced, or at least written down enough that we can then discuss a specific solution rather than something vague and hand wavy.
Can
so
I?
Go ahead, Peter.
I was going to suggest, why don't we declare a date, let's say 2 weeks from now, by which people who have solutions should like submit a draft in writing, and then in 2 weeks' time, not on a call, we can look at what's been submitted, and if there are solutions that we think are like worth discussing, we can have a working group call to see whether they like stand up to muster of like a reasonable amount of analysis. And if, based on the working group call, we have a solution that looks reasonable and looks like it might work, we can then bring that to a full statelessness call.
Yeah, I feel like, again, the only, not again, just in general, the only worry that I would have there is, yeah, that basically the next, I don't know, I'm not so sure that like how much time I'll have to work on this specifically over the next 2 weeks. So I'll only kind of return home.
We can choose a different date. I think 2 weeks was just meant as a straw man date, like a month.
Right.
Would that be better?
Yeah, but I also don't want to kind of keep like have that slip too much. So we could, yeah, if we want to pick a date, I feel like something like, I don't know, three weeks out or so makes sense. If we want to just say like as soon as we have proposals, we get back together, we could also do that.
I'm fine with that.
Hey, this is Justin from the Besu team. I think we love that idea. The date, not so much. Anything past London would be awesome. 2 weeks is, I hear what you're saying. It's just a placeholder.
Right. No, that makes sense. So then basically you're also saying that you'd prefer just the, once we have proposals, we'll continue from there approach. Is that right?
Yeah, I really like this idea. What I'm hearing is, hey, let's come up with an interface and a test suite, and then agree on what is in that test suite. What are we talking about? What are the different problems that we're trying to solve? And then we can start applying different solutions to those different aspects of the test suite.
Yeah, I personally think that sounds good. The only question is like, are we confident that this will happen if we just like go to asynchronous communication then for now, or is there basically there are enough teams that like internally will be working on this so that we'll make progress, or will we just kind of like come back 2 weeks from now and notice that no one really did anything, and so we are.
I promise that I will not work on this.
Right. I'm unsure if I can like to spend time on it within the next 2 weeks, but afterwards I'll definitely kind of work on this.
I'll take it back to the team and see what kind of commitment we can offer. Right now, I think I'm on Micah's page. I can promise you that I'll think about it, but I don't know about working on it. And again, I'm very new to the group. I'm still very behind as far as the thinking and understanding of the problem space. So that's going to add a lot to our ramp up.
Sure. Yeah. No. But I mean, it's really great to see you here and see you stay to the very bitter end here, just the 4 of us. But yeah. No, that sounds good though. So basically, like, we could also just say, like, we don't set a date now, but like we could just two weeks from now, once basically like, I don't know, we have London, and that should be in 2 weeks or something? Is that roughly well, it's 3 weeks from now, I guess, London. So but basically like 2 to 3 weeks from now, we just kind of like at least kind of come back together on the channels, like the communication channels, and then we see where people are at, and then we set a date for whenever we want to pick things back up and in what form. Does that sound good?
Yeah, it sounds good.
It's fine with me.
Okay. Yeah,
I'm
and also
happy
I
with that.
also definitely try and start working a bit, at least on sketching out the exact version of all of these different proposals that we talked about, that I personally think makes the most sense, or at least would be the ideal case. And yeah, hopefully we'll have something there soon. Okay, then I guess we'll leave it at that. Thanks all. I mean, thanks the 3 of you for coming. Yeah, so those were I think productive calls in general, and I'm definitely looking forward to kind of like keeping this active and really pushing for I don't know. I'm still like, on a meta point, I'm still kind of worried that all of this might end up being too complex for all codevs to even consider actually going forward with it. But if there's a shot for any of this to actually happen, I really want to make this happen. So, or at least help.
Yeah,
help make this
unfortunate.
happen.
It's unfortunate because we have to do something. Like, we can't just ignore this problem forever. Like, it has to be solved, the address space extension. The issue is we either solve it some way like we're talking about, or we launch ETH2, like an actual ETH2, like a separate chain that starts from scratch. I think it doesn't have this problem. Like, there are not a lot of good options here.
Right,
Which
but
is
I just feel like basically the point here is, like, we, for the longest time, we had the vision that once E2 comes around, we basically kind of deprecate the existing chain. We built this fancy new chain with execution environments and EWASM and everything, and now we decided against that. And I feel like not everyone has like fully realized yet what that means. We have to now make ready the ETH1 chain for 10 more years of flawless operation, and probably even more than that. And so, like, even though all of these kind of changes are not necessarily immediately pressing, they just have to happen anyway. So we might as well start facing those big decisions now.
Yeah.
So yeah.
Yeah, I mean, I think in the back of everybody's mind, I do encourage you, like, if we can't make this work, are there any other options on the table besides a brand new chain? Like, is there anything else? Like, even if it's extreme, it can't be possibly be more extreme than just starting a whole new blockchain. And so that's what's on my mind right now, is because I'm not convinced we can solve this in this way. And so in the back of my head, I'm trying to think, is there anything else we could do short of just forking off a whole new blockchain?
Yeah, that's a good point. But I mean, that is a topic for a different day. Yeah, I mean, I feel like we can definitely make static expiry work some other way, not as quite as well, but others. But like, at some point, we just have to kind of face the collision resistance problem. So yeah. In any case, that's then all for today, I would say, though. We should definitely follow up on this in general, but come to a close here. So thanks all, and talk to you all soon.
Thanks. See ya.
See ya.
Bye.